here we have a polynomial and they told us that 3 is a 0 and they want us to write it down as a factored version of this. So why is it useful to know that 3 is a 0? Well, if we know that 3 is a 0, then we automatically know that x minus 3 is a factor. And if I know a factor is 0, I can also do synthetic division. You put the 0 in the square and then write down the coefficients. So 1x to the third, negative 5x squared, 4x, and 6 is my constant. And then add multiply, so 1 plus nothing, multiply by 3, add, multiply by 3, add, multiply by 3, and I get no remainder, which also reinforces the idea because this was a factor divided in evenly. Well, picture what that says is now f of x, we just divided out this factor, and so this is what we're left with. So if this was on x to the third, this is on x to the square, x squared. So this says 1x squared minus 2x minus 2. So anytime you can divide out a factor, then hopefully maybe this we could factor, just our normal like foiling, guess and check factoring. If you can't, you could always solve it by quadratic formula. I'm assuming this one factors because they're asking us to write it as the product of linear factors. So what multiplies to negative 2 but adds to negative 2? So it doesn't look like this one factors. Alright, so what can we still do to solve it even if this piece doesn't factor? Well, this is quadratic, so even if I get this one factor out, I can just use quadratic formula. If it factors, that's obviously the fastest. That's why you want to check and see if that works first. So let's see if we can't solve this part using quadratic formula. So this is a is 1, b is negative 2, c is negative 2 also. So here's quadratic formula, and we're saying we're putting in negative 2 for b, so the negatives cancel there. And then negative 2 squared is 4, minus 4, a is 1, so I'm not going to put times 1 because it doesn't do anything. And c is negative 2, and then all over 2a, which is 2 times 1. So this says 2 plus or minus 4 plus 8, so square root of 12, all over 2. And then I can probably reduce that because square root of 12 is the same as square root of 4 square root of 3. And square root of 4 is 2. And then actually both of those are divisible by 2. So I can write this down as 1 plus or minus square root of 3. Alright, so why is this useful? Because if we were trying to write this all factored out, if you know a 0, you know a factor. Just like how they told us this, we automatically knew x minus that 0 was a factor. So now if we know that these two numbers are zeros, I know all the factors are going to look like x minus whatever my zeros were. Now be careful, this 1 plus square root of 3, say, is its own number, and so you need parentheses when you write minus. So if I know 3 is a 0, x minus 3 is a factor. If I know 1 plus square root of 3 is a 0, then x minus 1 plus square root of 3 is a factor. And so even for the ones where the factors don't work out nicely to be whole numbers, you can still write our original equation. If I FOILed all this out, it would give me the same thing as this. So if you know factors, you know zeros, and if you know zeros, you know factors. It's just x minus your answers.